Welcome to the Deep Dive. Today, we're really getting into the history of climate change. Not just the headlines you see now, but peeling back the layers to see how we actually got to this point.
It's quite a story, and maybe longer and more complex than many people realize. It involves, the Earth itself, scientific breakthroughs, and of course, human activity.
Exactly. And our plan for this deep dive is to walk through that timeline, using the insights from the sources we looked at. So, starting way back, before humans, through those first scientific clues, the industrial age, right up to today. Think of it as a way to quickly grasp the big historical picture that shapes everything we're dealing with now.
Sounds good. So where do we start? Way back.
Yeah, let's begin way, way back. Before humans were even around, the sources make it clear the Earth's climate wasn't static. It's always been changing, naturally.
Right? Over millions of years, we're talking huge swings, ice ages covering continents, then periods much warmer than today. Sharp changes sometimes. These weren't caused by us, obviously.
So what did cause them back then? The sources mentioned a few things.
Yeah, the big natural drivers, things like massive volcanic eruptions spewing gases and a dust.
Okay.
Changes in the Earth's orbit around the sun, subtle wobbles that shift how sunlight hits us over long periods.
Right, the Milankovitch cycles.
Exactly. And even changes in the sun's own energy output. These are planetary scale forces.
And the really crucial point here, which the sources emphasize, is the speed, or rather the lack of it.
Precisely. These natural shifts happen slowly. We're talking thousands, tens of thousands, even hundreds of thousands of years.
Which gave the planet, ecosystems, life itself, a chance to adjust, to adapt.
That slow pace is the key difference compared to what we'll get into later. It sets a baseline for understanding natural variability versus what's happening now.
Okay, so that's the deep past.
Yeah.
Then things start to shift with human understanding, right? The science starts to emerge.
Yes. Fast forward quite a bit to the 19th century. The 1800s, people start applying scientific methods to understand the atmosphere, how it works.
And this is where some maybe less famous names pop up. The sources mentioned Eunice Foote.
Yeah, Eunice Foote, 1856. It's a fascinating story. She did these experiments, quite simple, really, with glass cylinders, thermometers, and different gases inside.
What did she find?
She put them in the sun and measured how hot they got, and she found that the cylinder with carbon dioxide, KO Euros, got significantly warmer and stayed warmer longer than the one with just regular air.
So she basically demonstrated the greenhouse effect way back then.
Essentially, yes. She showed that Kara traps heat. The source mentioned an analogy like a blanket, but maybe think of it as making the atmosphere slightly better at holding on to heat.
It lets sunlight in, but slows down the heat getting back out.
Exactly, a fundamental discovery. And then jump forward about 40 years, and you have the Swedish scientist Svante Arrhenius.
Okay, his name is maybe a bit more familiar in this context.
Right. Building on work like Foote's and others, he was the first one to actually predict quantitatively that increasing KO from burning coal could warm the planet.
And he didn't just say warm, did he? The sources said he actually put a number on it.
He did. He calculated that doubling the KO in the atmosphere might raise global temperatures by something like 5 or 6 degrees Celsius.
Wow, over a century ago. And how does that compare to now?
Well, it's remarkably prescient. Modern estimates for KO doubling sensitivity often land somewhere in the 2.5 to 4.5 degrees Celsius range. So for the time, using basic principles, it was an incredible piece of insight.
It really shows the core science isn't new. But, as the sources point out, back then, this wasn't seen as an alarm bell.
No, not at all. It was more of a scientific curiosity, an interesting theory. Some even thought a bit of warming might be, beneficial, pushing back future ice ages.
It wasn't connected to any immediate sense of danger or large-scale human impact they could perceive yet.
Because the world was just entering this other transformative phase.
The Industrial Revolution.
Exactly.
Yeah.
A complete game changer, not driven by climate science, but by the desire for power, manufacturing, economic growth.
Right. And this meant burning fossil fuels, coal, then oil, then gas, on a scale never seen before.
Huge amounts to power factories, trains, ships, build cities. The whole infrastructure of the modern world was starting to be built on this foundation.
And the unintended consequence.
Massive amounts of co-euro pouring into the atmosphere. It wasn't really something people were tracking or worrying about initially.
The focus was all on progress, invention, building things. The climate impact was just invisible. An externality, as economists might say.
Pretty much. But the sources mark this as the real beginning of the accelerated change. This is when the human fingerprint on atmospheric composition starts to become significant, setting us on a different path from those slow natural cycles.
So, okay, 19th century.
Yep.
The basic science is understood. Industrial Revolution. The emissions start ramping up. What happens next in this story? How do we start measuring this?
That takes us into the 20th century, especially the mid-century, around the 1950s. Scientists started developing much more accurate ways to measure the concentration of gases like CO in the air.
And this is where Charles Keeling comes in.
Yes, Charles David Keeling. He started incredibly precise and continuous measurements from high up on Mauna Loa volcano in Hawaii, far from major industrial pollution sources,
Right there.
to get a clean sample of the background atmosphere, sort of the average air mixing around the northern hemisphere.
And his work led to the Keeling curve.
That's right. It's probably the most famous graph in climate science. It shows that iconic zigzag pattern.
Right, the up and down within each year.
That's the Earth breathing, basically. Plants taking up COs in spring and summer, releasing it in fall and winter. But crucially, underneath that yearly cycle
is a steady upward climb, year after year after year.
Unmistakably, it was direct, hard evidence that KO levels were rising, and rising consistently. It really moved things from theory to direct observation.
So the data is getting clearer. What are the warnings?
Well, the sources point to the 1980s as a time when the scientific warnings really started to ramp up. Major reports were coming out, climate models were getting more sophisticated.
Predicting significant warming if things continued.
Yes. The scientific community was increasingly sounding the alarm based on the accumulating evidence, the physics, the rising CO, the early model results.
But the reaction wasn't exactly immediate or universal, was it?
No. The sources note that, for a lot of people, policymakers, the public, it was still seen as maybe uncertain or a problem for the distant future, or maybe just too complex or inconvenient to really grapple with. There was a lag between the scientific consensus and broader action.
Which brings us closer to the present day.
Yeah.
The 21st century. When did things really shift from scientific warnings to, well, lived reality?
The 2000s onwards, really.
Yeah.
This is when the sources say the impacts described in the reports started becoming much more visible, much more tangible for people around the world.
We started seeing it.
Yeah. Things like the increase in frequency and intensity of wildfires in places like Australia and California. The dramatic speed up of glacier melt and ice sheets shrinking in Greenland and Antarctica, contributing to sea level rise.
Stronger storms.
More powerful hurricanes fueled by warmer ocean waters, and also the extremes of water, intense droughts in some regions, devastating floods in others.
So it moved from graphs and predictions to things people could actually see and experience in their communities.
Exactly. The abstract became real, and alongside this, the scientific consensus solidified even further.
With organizations like the IPCC.
Right, the Intergovernmental Panel on Climate Change. They synthesized vast amounts of research from scientists globally, and their reports became increasingly definitive, stating with extremely high confidence that human activities are the main driver of the warming we've observed since the mid-20th century.
So the history really connects the dots, from Foote's simple experiment, Arrhenius's calculation, the industrial boom, Keeling's curve, right through to the global impacts and scientific certainty we have today.
It's a long chain of events and understanding, and seeing that whole arc really underscores the situation.
But the sources are clear. This history lesson isn't just history. It's prologue.
Absolutely. The crucial point they make is that the story isn't finished. Far from it. The chapters being written right now by us are arguably the most important.
And this is where it connects directly to you, listening now. Understanding how we got here helps make sense of the choices we face.
Because those choices about how we generate energy, how we move around, what we consume, policies we support, they're all part of writing that next chapter.
And it's not all doom and gloom, is it? The sources mentioned a counter-narrative emerging.
Yes, definitely. They highlight a real sense of agency and action. You see it in youth movements demanding change, scientists continuing to innovate, activists pushing for policy shifts.
Even some businesses and governments starting to move, though maybe not fast enough for everyone.
Right. There's this growing, powerful call basically saying, enough. We need to protect the planet. We need to build a future that's cleaner, but also, importantly, more just and safer for everyone.
That idea of just future is key, too.
Absolutely. So yes, the history stretches back centuries, but the focus now has to be on the present and the future we're actively creating.
So that's the sweep of the history of climate change, drawn from the sources we reviewed. from deep time to this very moment.
A long journey, but one that brings us right to the challenges and opportunities of today.
Thank you for joining us for this deep dive. We hope tracing this history provides some valuable context. If you found it useful, maybe share it with someone else.
And we're always keen to hear your thoughts or ideas for other topics. You mentioned climate justice earlier.
Yes, this source has brought that up, and it feels like a really vital area we could delve into next time. What does climate justice actually mean in practice?
Definitely worth exploring.
Until then.
Stay curious, try to remain optimistic, and let's all be a bit kinder to our planet.